Alright, page 3 of your review packet, continuing on with our growth and decay formulas. We have y equals 525,000, and then this is growth again because we know that it is increasing, so that's going to be 1 plus 0.045 raised to the t power. So from now, it says 15 years from now, so that's what we're going to plug in for t, 525,000, 1.045 raised to the power of t, which is 15 in this case. And if we put that in our calculator and evaluate it, it will be worth $1,016,023.28. $28. For the next one, following the same model, you have 21,500. 1 now minus because it's declining. Now, 0.24. Some of you might be going, how do you term 0.24? That is not already in decimal. You still do need to divide that by 100 to get 0.0024 raised to your time. And in this case, again, 20 years from now, so you're going to plug in 20 for that value of t. So 21,500, 1 minus 0.0024 raised to the 20th power. So you're going to get 20,491.19, but since I can't have 1900ths of a bear, I'm just going to say about 20,491 bears. For number 19, we're going to have to work backwards for this one. Because this one you're not given the years. You're going to have to figure out from your y equals what it is. So if you put this in, you can also guess and check if you want to. But the easiest thing to do is just to use your table. 1 plus your rate of 0.125 raised to the t. And if you go to your calculator and go to y equals and plug that in, 250,000, and then 1.125, if you add those together, raised to the power of x. If you look at the graph, then when is it going to be about $400,000? And you're not going to see the graph, so I should probably have gone right to the table. Sorry about that. If you go right over to the table, you will see that at year 4, it will be worth more than $400,000. So you want 4 years. And again, that is, when is it going to be, it would look like this. So you'd put the 400,000 over on the other side of the equation, and then you would have the 250,000 here, and then 1.125 raised to the t. Okay, and I ran out of room there. Alright, so those are your word problems with growth decay, the basic form of them. Going down to the bottom of the page, we're describing the transformations, which means reflection. Is it stretched vertically? Or moved up and down? Okay, so those are your different options that you have to choose from. So for number 20, just looking at the equation, you'll see from here to here, the only thing that changed is that negative. And what that negative does is that it reflects it. And a reflection over the x-axis. And you would be able to see that if you put both of them in. From here to here, the only thing that changes is you have an x minus 2. And since that is in the exponent, then this moves the equation right 2 units. Now also this one has a negative on the 7, so you notice the negative 7, so this is also reflected. Same as in the first one over the x-axis. From here to here you have a plus 6, so that moves it 6 units up. Again, added or subtracted to the end moves up and down, add or subtract in the exponent moves it left, right. So here, from here to here, you have both exponent and at the end. So the plus 3 moves 3 units, and it moves it plus 3. You think it moves it to the right, but it actually moves it to the left. And the -4 does move it down, so 4 units down. And for the last one, you will see that we have a +2 at the end, so therefore this is just moved 2 units up. Okay. This concludes